The first guideline we will discuss when designing services is the single responsibility principle. This principle tells us that an object should have a single responsibility. This is often stated as having a single reason to change. Let's look at a bad example to see what I mean. Here I have a service called schedule. At the top, it gathers the data it needs, and then it returns an object with a list of methods. If you look, each of these methods has to do with scheduling, so it's reasonable to say that they belong in the schedule service. But looking closer, we can see that there's all kinds of responsibilities mixed into this class. It's responsible for giving out both student and instructor schedules. Because of this, it has a getSchedule and a getInstructorSchedule method. It has some methods that are about viewing class lists, but it also has methods about determining if something can be done. As the logic for determining if students can register for a class changes, this service will also have to change. If the logic about how to register a student for a class changes, then this service will have to change. If the logic about adding new classes to the course catalog changes, then this service will have to change. There's just too many reasons for change. Let's look at a better example. Here I have a registration service. We could conceivably have extracted this out of our schedule service. This service is simply responsible for the registration process. You can see that it brings in a collaborator to help it out so that it doesn't have to understand things that it doesn't care about. Now when this class changes, it will only be because the logic for registering a student has changed. The next principle we want to discuss is cohesion. A good service is cohesive. This is closely related to the last point, so we won't look at any code examples. Cohesion is the principle of having all the functionality of an object relate to the primary purpose of the object. Thinking back to our schedule service that was trying to do everything, that's a great example of a lack of cohesion. The next principle is loose coupling. A good service should be loosely coupled to any dependencies that it has. Look at the following code. This is the same code we were just looking at. You can see that the coupling between our class registration service and the policy service revolves around one method call. This is a nice loose coupling. The policy service can change its implementation a lot, and the class registration service wouldn't necessarily have to change. Now let's look at a tighter coupling. This service is much more tightly coupled to the policy service. If any of the logic around how policies are implemented changes, then our class registration service will probably have to change as well. This is not what we want. We want to make our services as loosely coupled as possible, so that if they change, the services that depend on them won't have to change. The next principle we will look at is the principle of good interface design. We'll look at a couple of examples. First, let's go right back to our bad class registration example. Notice how the policy service requires the class registration service to call 3 different methods to find out if a student can be registered for a class or not. This is a great example of a bad interface. The class registration service has to know so much about how the policy service does its job, and it has to do a lot of work to talk to the policy service. Let's look at another example. Here I have a controller that depends on the class registration service. You can see that I'm calling 2 methods on the class registration service. The first one adds the class to the student schedule, and the second one adds the student to the class registration list. This is not a very effective interface. Having to call 2 methods to get one task done is a bad interface indeed. Any situation where you call multiple methods to do a single job is less effective, even if in some parts of the application you might call only one of the 2 methods. You should add an additional method that incorporates the work of the 2 method calls together. Give your consumers of your services a break and make their job easy. Give them method names that are meaningful, that don't ask for too many parameters, and don't make them make multiple calls to do a single job. The last guideline we will discuss for services are to make them testable. Just like controllers, testability will help you stay away from other problems in your code. Testable services are loosely coupled, they tend to have good interfaces, and tend to be more cohesive. If you look back at this list of guidelines, you may notice that this list is essentially the list of good design techniques for a class or object in any language. That is on purpose. Services should be the meat of your application, and you should follow good design principles when building your services.